Welcome to solverfy, the place where learning becomes simple. If you're struggling with homework, assignment, or doubt in subjects, don't worry, you are in the right place.
All right, welcome back. So for this problem, we have basically the world right here, and you are standing at some point on it, and you are looking with a blue laser beam apparently, down to where you can see the horizon. All right, so the horizon is basically a point where you can't see anything further, right? So that's basically where your line of sight is tangent to the Earth surface. If it is tangent to the Earth's surface, it is perpendicular, right, at a 90-degree angle with the radius of the Earth. So here's the center of the Earth, and we draw this line out from the center to the surface. Then that line will be perpendicular to your line of sight. All right, we're going to draw one more line here in this equation. We're assuming you're standing up straight. And if that is the case, then you will, you will also form a line that, if you were to drill down, that goes straight to the center of the Earth. All right, and so now we have a triangle right here. Hope you are beginning to love triangles as much as I do at this point. So we got this triangle, and it's a right triangle. Those are the best kind of triangles. They make math easy, right? Easier at least. And for this problem, we need to know actually that the radius of the Earth, r, is equal to 6.38 times 10 to the 6 meters, and that we, right there, are 1.6 meters tall. All right, so because this is a right triangle, we can use Pythagorean's theorem. A squared plus b squared is equal to c squared. So c is our hypotenuse, right? And we can call this side A and side B right here. So side A is going to be equal to the radius of the Earth, right? 6.38 times 10 to the 6 meters, all squared, plus 6.38 times 10 to the 6 meters, plus 1.6 meters. Excuse me, sorry, I was doing that a little wrong. I'm going to erase that a little bit. All right, this right here should be our side B. So our side B is the distance we're looking for. All right, that is equal to 6.38 times 10 to the 6 meters plus our height, which is 1.6 meters. All right, and we square both sides. So we need to solve for B right here. So we're going to do some arranging and then some arithmetic here. 6.38 times 10 to the 6 meters squared. We're going to subtract this term from both sides. Doing that is going to give us 6.38 times 10 to the 6 meters plus 1.6 meters squared is equal to b squared. And then take the square root of all of that. Instead of writing that all out again, I'm just going to delete the squared on the b term right here. And just add a square root to this side. So there you have it. B is going to be equal, if you throw that into your calculator, you will find that B is equal to 4.4500 meters, 4,500 meters. And if you want to convert that to miles, 1 mile is equal to 1,609 meters. So if we do a little bit of unit conversion, we need something to cancel out the meters right here. So because this side is equal to this side, if we do 1 mile over 1,609 meters, then that is basically the same thing as multiplying by 1. So we will do that over here. 1 mile over 1,609 meters. And our meters are going to cancel out. And you will end up with about 2.8 miles. So that is how far you can see along the Earth's surface before you get to the horizon.